What is shear force? What is bending moment? And what is axial force? This is a concept which has brought a lot of issues to students. If a student is capable of drawing a shear force diagram and is capable of drawing a bending moment diagram, but then the students cannot define or describe what exactly is a shear force diagram. I mean, what exactly is this shear force and bending moment? I think it is so fundamental. I mean, it's so important that you understand what shear force really is, what bending moment really is, before you could go ahead and understand how to draw these diagrams, right? Ladies and gentlemen, I hope you're doing well wherever you are. My name is Olwich. I'm back here to continue the training. This channel is about engineering, architecture, and construction. We also deal with engineering survey here. Today, it is about bending moments and shear force, right? Yeah, because I thought before we go into drawing of these diagrams, let us first understand well what exactly these things are. So if you've really been having problems understanding what they are, then just keep it here. In a few minutes time, I'll be telling you what exactly they are. So assume that you have maybe let's take a cantilever beam. You have a cantilever. You'll pardon my drawings. I'm using a mouse, so it's quite hectic, and I will improve. For now, let us just survive with what we have. Assume you have a cantilever beam. That is the cantilever beam, right? Then in this cantilever beam, maybe you apply some axial force. You want this, you apply some axial load here. You want your beam to carry some axial load. You also want your beam to carry some traverse loading, right? You want the beam to carry some point load at this point. Well, let's say this one is P, this one is P, this load, let us call it P, let us call this one M, the axial load, right? Yeah, so we really want to see what is this shear force and what is this bending moment. Let us just take a simple look into this beam here. Now assume you cut a section at this point. Assume you cut some section at that point, and maybe say the distance from here to here is around the distance from here to here, maybe say it is X, right? Just call it X, right? Yeah, then what happens is, when you cut a section at this point, this load here will will pull this member down. Allow me use another color. So this force will try to move this member maybe to this location here. Let us just have a sketch of it. It will try to pull this member to this location if we cut that member at that point. We agree? Yeah, it will try to bring that member to that point, right? Then this force here, this axial force here, will try to bring this member, if we cut a section at that point, then this force will translate this member to this new location, maybe say right here. Okay, right? Then this force as well other than pulling this member downwards, this force has another effect, that it will try to rotate this member. We agree with that? So this force here will rotate this section here, so that member will be something like this. It will rotate because of that force, because that force is applied at a distance, so there is some bending there, so it will try to bend this member. Okay, it will try to bend this member like that. So these are the effects which this beam undergoes, right? It is trying to be pulled out, it is trying to be pushed down, then it is trying to be rotated, right? But remember, we made an assumption that we are cutting this beam at this point, right? But in reality, this beam has not been cut at this point. Are we together? Yeah, that means for this beam not to move in this direction, right, it must be restrained at this point. You get that? For this beam not to be moved in the downward direction, it has to be restrained at this point. Now, for this beam not to rotate, it has to be restrained at this point, right? That means we have internal stresses. Now let me just draw that sketch here again. So that means at this point we have internal stresses. We really don't know how they act. There's a complex thing, the issue of stresses, but we have stresses here which are keeping this beam in equilibrium so that it doesn't move in this direction, it doesn't rotate, and also it doesn't move in the downward direction. We have these stresses here, right? But for simplicity of engineering, you know, for simplicity of engineering, let me just clear these stresses here. For simplicity, alright, let me just clear this one, then I draw another one which is looking better. Well, for simplicity, we have this member here, right? Yeah, then there is this axial load which is acting at this point. For this member to remain in equilibrium, for this member not to move in this direction, right? For it not to move in this direction, then we must have force which is acting in the opposite direction to this axial load. This is the section at this point. Let me say this one is section AA or section 1-1. Section 1-1. Let me call it section 1-1, right? So this is the section 1-1, right? So for us to make sure that this beam is in equilibrium, then we must have an equal and opposite load, equal and opposite force to this load here, which is this one here. Let me call it NX. Let me call it NX. Right there. Then for this member to remain in equilibrium, for it not to be pushed downwards by this force here, you see this force here, for it not to push this member downwards, we must have an equal, you know, this is the load. For this member not to be pushed downwards this direction, right, we must have an equal and opposite force at this point. Let us call it Fy. Let us call it Fy. We are there. Then for this member here not to be rotated, as I said here, for this member not to be rotated, we must have some, you know, this member will be subject to bending. How does bending look like? Something like this, something like this. For this member not to bend, you know, we must have an equal and opposite, force to counter this force here. That is, we must have some force here. Let us call it mx. Mx is taking care of this bending here, is making sure that this beam doesn't bend, right? So look guys, for us to stop this beam from moving in this direction, we must apply an equal and opposite force at this point. This is the reaction, right? For us to stop this beam from moving in the downward direction, we must have some equal and opposite force at this point, right? Then for us to stop it from bending, we must have some equal and opposite force at this point. It's at this point that I now introduce to you this famous guys. I'm introducing to you this famous guys, Fy, which you really need to stop this beam from moving downwards, is called the shear force. That is the shear force, right? The mx the mx which you need to stop this member from rotating is called the bending moment. That is the bending moment. That is the bending moment. Then of course the force which you really need to stop this member from moving in the lateral direction, that is called axial force. That is the axial force. So ladies and gentlemen, these are the famous bending moment, this is the famous shear force, and this is the famous axial force. I hope if you watch this video till the end, you won't be frustrated anymore by the idea of bending moment, by the idea of shear force, and by the idea of axial force. I've tried to make it as simple as I can, with zero numbers, zero mathematics. The next time we'll do a video where we include some calculations, and we'll also do a video to see how we can draw the shear force diagrams and also the bending moment diagrams. Well, I intend to really stop there. Is that now? If there are any questions, kindly drop them in the comment section, so that whenever I have time, I will always pass through and respond appropriately. I would also love to hear thinking, and if you really want to see such videos again, kindly subscribe to this channel. More yet to come. Please make sure that you also like the video if it makes you happy, and also share with friends so that they also learn from this. Otherwise, I do appreciate your time. See you in the next video. Thank you.